Hello my friends, I'm super excited to start now a part of this course that we've been excitedly waiting for. I'm talking of course about deep learning. You just got the amazing intuition lectures by Kirill, and so now you understand that what deep learning consists of is building an artificial brain. So there you go my friends, now we're about to build an artificial brain using the brand new TensorFlow 2.0. This will be super exciting. We will really build a deep neural network with neurons and fully connected layers connecting these neurons, and we will apply all this to a business problem as usual. And now that we are, quite advanced in the course, the dataset we'll be working on looks more like a real-world dataset with many observations and many features, and you'll see that we will actually have to not only use our data preprocessing template, but also use some of the tools of our data preprocessing toolkit. So, are you ready? Are you ready to go next level? Indeed, now we're about to do some more advanced machine learning, and so I'm super excited that you're even pushing further your expertise in machine learning. Alright, so let's do this, but first, let's just make sure everyone here is on the same page. So this is the folder of the whole machine learning A to Z with all the codes and data sets. I gave you the link to this folder right before this tutorial, so make sure to connect to it. And now there we go, let's enter part 8, deep learning, with first the classic artificial neural network, meaning the fully connected neural network with only fully connected layers, with no convolutional layers or other types of layers. Here we will just have an input vector containing different features, and we will predict an outcome which will be a binary variable, because you have to know that actually artificial neural networks can be both used for regression or classification. And here we're going to do it for classification. However, note that we have a free course on artificial neural network in which this time we built an artificial neural network for regression. So make sure to check it out. I will think of including the link somewhere so that you can get it as well. But it's really good. You will have both cases, the classification case with this course and the regression case with the other free course. All right. So now, as usual, we're going to start with Python. And there we go. This folder contains the implementation first, artificial neural network.ipynb, which you can either open with Jupyter Notebook or Google Colaboratory. And we have, of course, our dataset, which I'm going to explain right now. All right, so as you can see, as I told you, it looks indeed more like a real-world dataset, right? For the first time, our dataset takes the full screen here, because indeed this time we have many features, starting from here up to this one and the dependent variable right here. All right, so let me explain what this is about. This is the dataset of a bank which collected some informations about their customers. These informations are, row number, that's just a non-relevant feature, we will get rid of it. Then the customer ID, that's just the identification key of each customer. The surname, the credit score, the geography, meaning the country the customer lives in, the gender, the age, the tenure, meaning the number of years they have been in the bank, the balance, meaning the amount of money they have on their account, the number of products they use from the bank, like a credit card or a checkbook or a MasterCard or even a loan or home loan, any banking product. Okay, so that's the number of products each customer has. Then has credit card, yes or no, meaning that this variable is equal to 1 if the customer has a credit card and 0 otherwise. Is active member, meaning is the customer active? Is he or she using the bank, connecting to its account or using its credit card or any other card, Let's say they have some measurement system to measure if a customer is active or not. And 1 means, of course, that the customer is active. And 0 means that it is inactive, okay? Then estimated salary. Well, the salary of the customer estimated by the bank. And that's it. That's the last feature. And then the last column here, exited, is the dependent variable. And it tells if yes or no, the customer stayed in the bank or left the bank. 1 means that it left the bank, as in exited equals yes, and 0 means that the customer stayed in the bank, as in exited equals no. So what happened in reality is that this bank actually observed their customers for a certain period of time, let's say 6 months. They observed if during the 6 months they left the bank or stayed in the bank, and they gathered these outcomes in this last dependent variable. And at the same time, they got all these features, to guess what? understand the correlations between these features and the fact whether or not the customer stays in the bank or leaves the bank. And that makes sense, right? Because a bank wants to have the maximum customers, right? That's how they make money. The more customers they have, the more they have money in the bank, and the more they make money from the diverse products they offer to their customers. So of course their interest is to keep the maximum customers, and therefore they made this data set to understand the reasons somehow why customers leave the bank. And mostly, once they manage to build a predictive model that can predict if any new customer leaves the bank, a model that was trained, of course, on this dataset, well, they will deploy this model on new customers. And for all the customers where the model predicts that the customer leaves the bank, well, they will be prepared and they might do some special offer to the customer so that it will stay in the bank. You see? So all this is to prevent the maximum customers from leaving the bank. And why is this called churn modeling? Because customer churn means exactly the situation where some customers exit, become no longer a customer. All right? And of course, the bank has asked you, the most talented data scientist, to make this predictive model, to first train it on this data set to understand the correlations of all these features and the dependent variable, and then to deploy this model on future customers. And you will see that in the implementation, we will actually deploy the future machine learning model we'll get on a different customer, not part of this data set, so as to predict if this new customer will stay in the bank or leave the bank. And even better than this, we will actually predict the probability that this customer leaves the bank. So we have a lot to do ahead of us, but I'm super excited because deep learning is a fascinating branch of machine learning. So let's start right away and let's open our implementation, artificial neural network.ipynb, which you can feel free to open with either Google Collaboratory, as I'm about to do, or Jupyter Notebook. As you want, just make sure you feel comfortable coding on your favorite IDE. All right, so now the implementation is opening, laying it out the notebook, perfect. That's the implementation, once again in read-only mode. So right now we will click File here to create a copy of this implementation. And as usual, we will re-implement all this from scratch so that we can really learn by doing. All right, so that's the copy. Now let's remove all the cells, right? This one, not the text cells, of course, because we want to keep the well-highlighted structure of this implementation, but let's definitely remove the code cells. So there are many of them, so you will actually have a bit of time doing it, but it's not that long, it's fine. There is a long data preprocessing phase and then a long phase of building the neural network, and I really gave the details of the implementation so you will actually see many steps, all right? And there are so many steps that I actually added a level of structure because, as you can see, the full implementation is divided into 3 parts, right? There is a homework at the end, the solution. So let me not show it to you. And that's almost the end. Confusion matrix and perfect. All right. Okay, so as you saw, this is a long implementation. This will be a long part, but it is absolutely worth it. Deep learning is one of the most powerful branches of machine learning. Okay, so let's see. We start first by importing the libraries as usual, and then we enter part 1, data preprocessing. So that's the first part of the whole implementation, structured in 4 parts, which are the following. Part 1, data preprocessing. Part 2, building the ANN. Part 3, training the ANN. And part 4, making the predictions and evaluating the model. And then in each part, well, we have the different steps. In part 1, data preprocessing, we'll first import the dataset, of course. Then we'll have some data preprocessing to do, not only the classic steps of the template, but also some extra tools, and we will see that together. Then in part 2, we will first initialize the ANN. We will add an input layer and the first hidden layer to our artificial brain. Then we'll add the second hidden layer, then the output layer. Then in the next part 3, training the ANN, we will first start by compiling the ANN to, an optimizer and a loss function. Then we will train the ANN on the training set. And finally, in part 4, well, we will deploy our model in production to predict the result of a single observation, meaning to predict if a new customer will stay or leave the bank. Then we will predict the test set results to, get that Y-pred vector to eventually make the confusion matrix with the final accuracy. Alright, so once again, as you can see, this implementation is pretty long, so make sure to have full energy and full motivation for this, because we have a long but yet exciting journey in front of us. So as soon as you're ready, well, meet me in the next tutorial to smash this implementation. And until then, enjoy machine learning.